flame atomic emission spectroscopy or FAES. Okay, this instrument is used to measure the intensity of the emitted radiation. Okay, macam mana emitted radiation boleh berlaku? Okay, this happen when the atom at the excited state move back to its original state or ground state and emit a photon or radiation. Okay, for in the FAES, this intensity of the emitted radiation is measured. Okay, what caused the emission to occur? Macam mana boleh emission ni boleh berlaku? Okay, sebab dalam flame, okay, your sample is atomized dalam flame kan, dia jadi atom dalam flame, and then sebab in the flame the temperature is very high, so your atom, the high temperature of flame will cause the excitation of atom. And then bila excitation occur, it move from ground state to high energy state. And then high excited state ni is not a very stable state, so it can move back to its original state and emit a photon. Okay, or radiation. Okay, this emitted radiation, intensity of this emitted radiation will be measured in this case. Okay, so dalam FAES, flame ni akan act as the atomizer and at the same time as the excitation source. Okay, the emitted radiation will go to the monochromator and will be detected by the detector. Okay, scanning instrument can detect multiple elements, many lines detected, so sometimes it is a quantitatively difficult method. Okay, mungkin daripada flame ni dia akan emit juga the radiation from the combustion product. Okay, so source can be flame, but more commonly plasma is used because it is much hotter. Okay, plasma ni adalah salah satu atomizer jugalah. Okay, and then the temperature for plasma is higher lah if compared to the flame. Okay, so each element emits its own characteristic line spectrum. Okay, daripada flame ni, macam mana kita nak tahu tu adalah matter of interest kita yang emit radiation tu? Okay, sebabnya each element, setiap elemen atau setiap metal akan emit its own characteristic line spectrum. Quantitative analysis can be performed here by observing what wavelengths are emitted and comparing this with various standards. Okay, so quantitative analysis sama juga macam AAS, absorption spectroscopy, is to determine the concentration of the metal of interest. So untuk tahu concentration macam sama juga, kita kena compare dengan standard calibration curve method ataupun standard addition method. Okay, so dalam AES ni juga kita boleh qualitative and quantitative. Qualitative ni nak tahu what element is present in the in our sample and also what is the concentration of the metal of interest. Okay, wavelength of emitted radiation indicate what element is present, qualitative, and radiation intensity indicate how much of the element is present, ni quantitative. Okay, maksudnya the higher the intensity of the emitted radiation, the higher the concentration lah. Okay, so macam ni lah. The plot for FAES is the intensity versus concentration. But kalau dalam AES hari tu, absorbent versus concentration kan. Okay. So automatically this AES doesn't follow the Beer's law. Okay, sebab Beer's law tu absorbent equal to epsilon kali B kali C. Tapi dalam AES, emission spectroscopy, kita tak nak measure the absorbent, but kita nak measure the intensity of the emitted radiation. Okay, so ni relationship dia. The higher the intensity of the radiation, emitted radiation, the higher the concentration. Okay, these are the components inside the AES instrument. Okay, so macam biasa ada nebulizer, ada burner. Okay, so the sample is aspirated through the capillary and find the create an aerosol, akan bercampur dengan oxygen and fuel and akan be introduced into the flame. Okay, so inside the flame, your sample will be atomized. Okay, so due to the high temperature inside the flame, your sample will become excited, and then it is not a stable state, excited state, so it will go back to its ground state and emit the radiation, characteristic radiation, and then it will pass through the wavelength selector, detector and signal processor macam biasa. Ini adalah proses dia. Okay, so the type of atomizer. Okay, there are 4 types of atomizer. So dalam FAES kita guna flame. However, using flame as excitation is only suitable for light element. Contohnya sodium, potassium and calcium, group 1 dengan group 2 element. Tapi this normal flame are not hot enough to excite heavy metal and emit light. Dia tak cukup panas untuk cause excitation of heavy metal. So, alternative dia kita akan guna plasma lah. Okay, so interference, you all ingat lagi interference dekat AAS. Okay, this is also the same lah, spectral interference and also the chemical interference. Okay, for disadvantage of FAES, okay, due to the interference and also due to the self-absorption. Okay, macam mana self-absorption ni boleh berlaku? Self-absorption ni bila photon emitted by excited atom is absorbed again by the ground state atom in the flame. Okay, so in the flame ni, due to the high temperature of the flame, akan ada atom yang being excited dan akan ada juga yang still dalam ground state. So bila excited atom ni move back to its original state, ia akan emit radiation, emit photon. So instead of being they go to the monochromator, go to the detector, this radiation ni diabsorb pula oleh ground state atom. So this will cause the inaccuracy lah dalam bacaan tu. Okay, ni kita panggil sebagai self-absorption. Okay, untuk flame instability, okay, sebab dalam AES ni the atom is being excited by the high temperature of the flame, and then the emission by the excited atom ni will emit the radiation yang akan di-measure. So, the temperature of the flame ataupun flame instability ataupun the temperature variation inside the flame ni akan affect FAES ni. Contohnya, bila at high temperature, lagi banyak atom yang boleh become excited and this will affect the emitted radiation. So kalau flame instability, dia akan cause inaccuracy lah. Okay, kalau sekejap high temperature, sekejap low temperature, dia akan menyebabkan bacaan tak emitted radiation measured tu tak accurate. Okay, lepas tu high emission background. Okay, high emission background ni, instead of you punya sample, ada juga emission from the background. Background ni ada elemen beside aside your sample, contohnya combustion product ke apa ke. Okay, so the relationship between AAS dan AES. Okay, kalau AES measure the emitted radiation by the excited atom, and then this intensity of the emitted radiation can be related to concentration. Tapi untuk AAS, apa yang di measure adalah radiation absorbed by the unexcited atom. Okay, so untuk AES, dia depends on the number of excited atom and is greatly influenced by the temperature variation. Dan untuk AAS, ia adalah sebaliknya lah. Okay, so kalau tengok dalam AAS ada light source. Sebab dia nak absorb this radiation from this light source. Tapi untuk AES, there is no light source. Sebabnya dia tak nak measure the absorbed radiation, but dia nak measure the emitted radiation, in which the emitted radiation ni berlaku due to the excitation daripada flame ni lah. Okay, the flame is also act as the excitation source, which will cause excitation of our atom to its higher energy state or excited state, and bila dia turun balik ke ground state, dia akan emit radiation, emit its characteristic radiation. Okay, lepas tu sama je proses dia lepas tu. Okay, so ni adalah comparison between AAS dengan AES yang guna flame. Okay, untuk flame, you boleh baca sendiri untuk use of flame. Kalau dalam atomic absorption, dia guna as atomization only. Tapi untuk atomic emission, dia guna as atomization and also as excitation source. Okay, so kita move to plasma. Okay, macam kita tahu, plasma will ada lagi higher temperature if compared to flame. Okay, so these are the three types of plasma, and the most commonly used is ICP or inductively coupled plasma. Okay, macam mana apa yang berlaku inside this inductively coupled plasma is dia ada 3 concentric quartz tube. Okay, 1, 2, 3 concentric quartz tube ni. Okay, apa yang berlaku dekat sini, bila the switch of the torch is on, dia akan supply the radio frequency. Okay, and then this radio frequency will pass through the coil. Okay, ni coil will pass through the coil and induce the magnetic field dalam ni. And then at the same time, the argon gas, okay, dalam inductively coupled plasma ni dia akan guna inert gas. For example, the argon gas. Argon gas ni akan masuk through sini and go to the magnetic field ni and akan berlaku spark. Okay, the spark ni akan cause the ionization of the gas to occur, in which the argon gas akan being ionized and dia akan form argon ion plus electron. Okay, lepas tu, okay, dia akan, okay, the spark will generate argon ion which are held in the magnetic field. Okay, kat sinilah magnetic field ni, and dia akan collide with other argon atom to produce more ion, and this process akan produce more and more ion lah, sebab argon atom ataupun argon gas akan keep on being supply kat sini. And then the heat is produced yang akan memproducekan plasma akan being produced due to the inelastic collision between the argon atom and juga argon ion. So ni akan menyebabkan plasma lah, keluar plasma which has the high temperature. So argon in outer tube swirls to keep plasma above the tube. Okay, ada kalau tengok ada tangent argon plasma akan masuk tangentially ikut sini, and this argon in outer tube dipanggil akan keep plasma above the tube so that it will not melt the instrument lah, sebab dia akan panas kan. So ni untuk stabilize kan dia punya temperature. Okay, untuk plasma appearance dia ada excitation region, the bright white donut shaped region at the top of the torch. And this bahagian akan excite and ionize atom. Temperature about 8,000 to 10,000. Okay, kat sini lah. Okay, kat torch ni. And the observation region adalah dekat 1,000 hingga 8,000. Okay, dekat atas ni. Okay, for sample introduction inside the plasma, kalau untuk liquid sample sama je dengan macam AAS dengan AES, ada nebulizer. Untuk solid sample, kita guna electrothermal atomization. Okay, so apa kelebihan ICP AES dengan FAES ni? Apa yang membezakan dia adalah dia punya atomizer. Yang ni ICP, plasma, yang ni flame. Okay, of course, dia punya temperature 2 or 3 times higher and akan cause higher atomization and excitation efficiencies. Okay, kurang chemical interference sebab dia ada high temperature. Lepas tu, dalam ni dia guna argon gas which will minimize the oxidation of the analyte sebab argon ni adalah inert gas group 18. Lepas tu dia ada short optical path length yang akan minimize the self absorption. Okay, short optical path length. So kalau dalam AAS kita nak long wide optical path length kan, sebab A equal to epsilon kali B kali C. Okay, path length ni equal to B. Okay, so kita nak high B sebab high B will cause high absorbance. Okay, linear calibration curve can cover up to 5 orders of magnitude. Okay, ICP AES ni juga ada lower detection limit. Okay, detection limit adalah the lowest quantity of element that can be detected by the instrument lah. Okay, so dia ada lower detection limit sebab dia ada high temperature yang akan increase the amount of the excited state atom. And then satu lagi, sebab dalam plasma environment tu ada higher population of electrons due to the ionization of argon gas. Okay, dia ionize argon gas dalam plasma tu tadi untuk membentuk plasma yang ada high temperature tu, argon gas akan di-ionize dan kan ada berbentuk juga elektron. So dalam plasma environment tu dah ada banyak elektron, so dia akan minimize formation of another cation lah. So dia akan minimize the interference of ionization. Okay, so untuk inductively coupled plasma tadi yang saya duk terangkan tadi macam mana plasma boleh terbentuk tu tadi. So lepas plasma tu terbentuk barulah sampel akan masuk lah dan akan berlaku atomization and all kat dalam ni lah. Sama juga proses macam dalam flame.